Yes, thanks. Welcome, everybody. Thanks for coming. Yes, don't feel you have to turn your camera on, but it's always great to look out there because then I can see your expression. You know, we've got Graham Greene's unflinchingly serious expression. Oh, no, he's getting some animation now. That's good. And it's good to see your reactions. Good to see people are out there participating. I see a lot of familiar faces and names. I just saw Christine Baxter there a second ago. I remember Christine. How are you doing? And Andrea, Greg Zapperzan, Colin Story. Yes, Barry. Yeah, a lot of familiar names. Dane Standfast, name from the past. Welcome, Dane. Yeah, wow, so many people. Awesome. Happy to have you here. You know, the Mitigator Round Table was something we've done how many times, Pam? I think at least twice before in person.
I think just twice, yeah.
Just twice, yeah. I don't know why we don't do it every time because we had so many great comments and everyone seemed to really enjoy themselves because this is the time when you can crowdsource some of your ideas, right? We can spitball, throw out some stuff, find out what other people are doing, which is good, connecting people, mitigators with best practice, which is awesome. And hopefully at the end of the day, everyone comes away with something unexpected, something interesting, something they want to pursue, or they just have a good time. So thanks, everybody. Oh, Lance Butler, how you doing? I see you there. Jeff LeBlanc is driving somewhere, a big vehicle. Oh, he's smiling out. He's giving us the peace sign. Graham Cooper, thanks for joining us again. Awesome, you guys are turning on your cameras. You don't have to, but it's awesome to see your expressions. We're gonna have kind of an open format. I believe anyone can unmute themselves at any time, right, Pam? You can, okay, yeah, sure.
Yeah.
So it's informal, you can unmute yourself, say whatever you want. Just be mindful to keep your mute button on if you can, because it's easy to forget and then you're coughing and then some of the phone's ringing, someone's talking to you all at the same time. We have so many people. Our last session, we had up to 60 people for the morning session, right? Which was the sniffer discussion. And we can wrap that up or continue it here if we want to. And in this session, looks like we're doing about the same because I got 3 pages of people on our list.
62, depending on which list I look at.
Wow, incredible, 62. Okay, well, joining me today, I have some special guest stars. Eric Bjornson from Radon Matters in Winnipeg, and Eric has helped facilitate these Mitigator roundtables in the past, and we always had a good time doing that because everyone has a different perspective, so it's nice to be able to draw on Eric's expertise, which spans energy efficient buildings and of course radon and God knows what other venture he's up to at the moment. So good to have Eric here with us. Thanks, Eric. And Doug Clatter, of course, a man that needs no introduction, the legendary, the one, the only Douglas Clatter. And if we're lucky, maybe he'll pull out a guitar or something and start playing some music for us. But we might need to get a few beers or something into him first. And it's a bit early for that. Thanks for joining us, Doug. Very much appreciated. I know Doug's got to run to a guitar lesson or something afterwards, right?
Right. It's my pleasure to join. Thank you for asking me. And I see a lot of names and faces that I recognize going back a number of years. So thank you very much. I'll try to contribute as much as I can.
That American experience plus your international experience. Of course, you are really well-rounded in working level measurements and radon decay products. So that's something that we don't talk about a lot. So you're gonna be able to add something to the conversation that goes in that direction as well. Plus internationally, I mean, you've worked in Korea and Japan and all over the world. We love to hear about that. And you're a real pioneer. That's awesome. And everybody else here is an expert in some aspect of what they're doing. So we want to hear from you guys as well. There is no format for this. The direction that we go makes no difference. Oh, Eric, you got your son's there. Look, want something? She came to bring you a milkshake or something. That's what I do for my kid. So what can we talk about? I think everything's on the table. Customers, how do you find them? How do you get them? Tools, what are the best tools? What are you using for what? Diagnostics, of course, how do you do such and such? Specialized tools like sniffers, new products that are on the market, coatings, I don't know, whatever you want to talk about. So we need to pick somebody to come up with something to start. How about Graham Cooper? Graham's always got some good ideas. I'm sure there's a lot on his mind right now. Graham, why don't you get this snowball rolling by giving us something you want to talk about?
One thing I wanted to bring up was documentation for mitigators. So when we do a job, of course, we like to provide a nice booklet of information and give something that's definitely leaps and bounds above the non-certified professionals. So I just wanted to see what others are doing as well. And is there sort of a way that maybe as professionals we standardize this as part of our certification, or do we still leave this up to the individual business owner? So yeah, I'd like to hear what others feel about that.
You know, that's actually a great topic there. I'm just looking to see if I have my documentation on my iPad, which I think I do. So maybe I'll just get someone else to mention it while I queue this up. I'll at least show you what I do. That's a fantastic topic. But you mentioned two things. One was, what's best practice for documentation? How can it help us differentiate ourselves from uncertified people? Of course, there's nothing stopping uncertified people from documenting work either, mind you. And two, standardization. Those are two very interesting points you make, and they're different in a way. Standardization is one I'm very interested in. Standardization is good and bad. If we're all completely equal, then you're no better than anyone else. So standardization reduces your ability to differentiate yourself, right? So if we all did the same work every time, we'd have less differentiation. And that's currently kind of the way it works, in that the certified mitigator list is just a list of people who all appear equally qualified to do that work. So I'm sensitive to reducing my edge, let's say. Having said that, documentation is so important, and it's a core concept, I believe, of our certification process. And in fact, it's embedded in our documentation. It is a requirement of our certification that we document these systems. And maybe someone can dig up 149.12 and we'll find the actual paragraph that talks about why documentation is required. So technically, if you're not documenting your systems, you are not doing a certified scope of work, and potentially you should be delisted, because a certified person has a scope of work that they do. It includes design, it includes documentation, includes post-mitigation measurements, it includes a bunch of stuff. If you're not doing all that stuff, you're not certified, really. Now, we're not enforcing this. When I say we, I'm not speaking for CARST or for C-NRPP, but it's not really being enforced that rigorously. So it's a little bit of the Wild West. But I believe if you're not doing all that stuff, you're not doing a certified scope of work. And your idea of standardizing documentation, or at least seeding it out there, providing training, providing a platform to spring off of, I think makes a lot of sense, because it's not being done, and there's not a fair playing field. Bob, were you just raising your hand, or are you swatting at something?
No, I'm raising my hand to ask another question. And it ties into this. I'm the chair of the mitigation for 149.11 and 149.12 for the mitigation section. And if anybody's got anything they want to see changed, something they have a difficulty with, any of that piece, including the documentation, please put it forward to me in an email. You can find me on several different ways, but it's Bob at mr-radon.ca. Please send it to me.
Okay, great. Thanks, Bob. Now, .11, of course, is new builds. So documentation probably has a role to play, but it's a little bit different in a new construction where you're doing a rough-in potentially than actually construction.
Potentially, we're taking active systems out of 11 and leaving it in 12, which is so that there's not a, I have one personal reason, and it's trying not to have active systems become a requirement that we pull a permit every time we do one.
Yep.
Is that but the documentation piece is a big piece of that 12, or where we think we're going to go with 12.
Just because not everybody knows what 11 and 12 is, it's the CGSB standard. For 11 is the new construction CGSB standard, and 12 is the existing construction CGSB standard. So the idea is that it may be that level 3 or the active system is taken out of the new construction CGSB standard and will just be in the existing construction. And just a note, if you email Bob, I'm helping him with admin And I know sometimes emails go awry. So CC me on that and we'll make sure we work together on that, right, Bob?
I couldn't do it without you, Pam.
Okay, well, here, I'm just going to run through very quickly to get this thing rolling. Some of the elements that I think are important in documentation for the design construction of a radon system. We'll just go through this quickly. It just happened to be on my iPad, so we'll just go through it quickly. So yeah, this is something I would do on site, and I'll just run through what the information is so you can decide what's important. But here's what I think is the minimum amount of information we need to provide documentation to a customer. Well, there's nothing too much here. I've got the date, my name, and the file number and whatnot. I think a tailboard of some sort talking about safety issues that could exist on the site might be important, and you could have your employees sign that so you can show it's part of your safety plan. I record natural pressures, outside temperature, design pressure, and target pressure so that we know what we're dealing with. What am I trying to accomplish on this particular job, and how do I know I've accomplished it? One thing I just want to mention here is you see I have target pressure. I don't know if you can see it, how small it is, but natural pressure is what we're measuring under the slab under prevailing conditions. In this case, 1.7 pascals. The outside temperature is self-explanatory, and you know why we need that. We need to know that to get our design pressure. I multiply my natural pressure by my temperature adjustment factor based on that outside air temperature. And in this particular house, I determined I had a 3.8 Pascal design pressure. In other words, middle of winter, cold weather, I may see as much as 3.8 Pascals under that slab, even though I'm seeing 1.7 right now. And this is something that actually is not actually taught. It's reading between the lines. And it's very important, and we're going to add it back in, which is your target pressure. What pressure do you need to achieve? And it is not the 3.8, and it is not the 1.7. It is 1.7 minus 3.8. It's your natural minus your design. So in this case, at this particular moment in time, I needed to demonstrate that I could get a minus 2.1 Pascal pressure under that slab to demonstrate that I could fix it. That's what I did. I have room for other pressures in case the HVAC is influencing it. I could document it there. How am I doing my diagnostics? In this case, it was a PFEDK, and I documented what the settings were, but it could also be our old-fashioned vacuum cleaner orifice plate method. Communication locations, I think we need to document where they are in that footprint by taking pictures, and here I could have up to 6 of them. Here's a matrix showing a combination of suction holes. There could be many suction holes. With communication holes, there could be many of those. So I could build a matrix out here showing what I could achieve at different communication holes from different suction holes. A crudely drawn floor plan, so I have an idea of where my communication holes are compared to where my suction points were, and I always use the stairs as a reference. System curve. This is an output right from the PFEDK, which is a fantastic tool, which actually gives us a lot of information. This forms the backbone of our design. Oh, I've done something now. Hang on. What have I done? Oh, I think I've shrunk. There we go. Okay, there we go. Yeah, some notes on which my recommended fan is and any comments about how it's performing. Bunch of as-built photos, where the fan was, what the fan serial number is, manometer reading, venting location, ceiling, and just miscellaneous photos of all the work we've done. You know, radon systems are like icebergs. So I think we need to demonstrate to the customers what we did. Otherwise, they can look pretty underwhelming, right? A little piece of pipe and a fan. And the documentation is one of the ways that we use to demonstrate what we did. And this documentation is important because A, it's required, and B, maybe you're talking to the husband or the wife, and at the end of the day, they're like, so what happened? How did it go? How did the thing go? And like, well, I think it went okay. They came, they went, they said it should be fine. And yeah, I don't know. It's much better they have some documentation. Then they can share it. Here, honey, I've got the documentation. He walks you through all of it. I've even recorded a video for them. Sometimes it's usually the wife, but it could be the husband. Gee, I wish my spouse was here. He'd really want to see what you're doing right now. And I'm like, have you got an iPhone? Okay, put the video on. And then boom, I'm on and I'm going through all my pressures and I show them. It takes no time and it seems to work really well. So documentation is critical because if you don't document it, I believe you're not demonstrating that you designed it. If you didn't design it, now you're not doing certified scope of work. You're just doing a poke and hope. So with that, maybe let's, yeah.
One question, in there, do you have the energy consumption of the fan?
No, not explicitly. I have which fan we use.
That is in the standard.
Yes. Who's speaking?
That's
Who's gonna be
Barry.
my hat tenor?
Barry.
Sorry, who?
Barry.
Very Tchaikovsky.
Barry.
Yes.
Tchaikovsky.
Okay, Barry, it's an important point. Your documentation doesn't just consist of one thing. The documentation is a bunch of things. And one of the things is something like this that could be done on site or at home and could be emailed to the person. But don't forget, documentation also consists of the labeling, right? So we do have labeling on our fan, typically next to the YouTube, and that has additional information such as what the YouTube reading is, what the energy consumption of the fan is, what your certification number is. I don't have certification number in this documentation. Of course, I could add it, makes no difference. So I'm just pushing back on you to say that the documentation isn't one thing. It's the culmination of all the leave behinds. Does that make sense? Or Pam, do you want to chime in? Or Eric, what do you think about that question? Does everything have to be in one place?
Ideally, I guess from the stuff that you're going to keep on your file, ideally in one place, and then maybe have certain amounts of it that you share with the client, certain amounts you share with your installers, and certain amount you just keep on record for any future service calls or troubleshooting. I think that's one of the biggest advantages of keeping good documentation is you know where you left things when you walked away. So if you come back and anything's different, that gives you an idea of where to start looking.
100%. 100%. Doug, what's being done for documentation in the States? It's not that much, I don't think, right? Because on the listserv, we saw some pushback on people even having to take a single pressure field extension measurement. What's being done in there? It must be the whole range from awesome to limited.
The intent of a lot of documentation down here is not so much on the science side as it is having a document for the occupant to know how to interpret the measurements, the YouTube, what the system is, so it can transcend ownership. So it's more geared towards the owner of the house or owner of the building, as opposed to, say, you as the mitigator. So people keep that information in their own files. So as you were talking, I threw this up on the board. I don't know if you can see it, but the key things we have here is a description of the system, how it works with a diagram or photos. Individual photos of components don't necessarily, gosh, is that backwards for everybody? That's
no,
weird.
just for you. There's a setting on your video that you could change.
Okay, that's weird. And, you know, kind of a stick diagram so they understand what's going on, and then have component pictures rather than just component pictures. Interpretation of the indicator, because a lot of people think sometimes the YouTube measurement is actually a radon meter. So when it gets to 0, they're really happy when the system's not functioning. Who installed it, contact information, certification number, individual component warranties, post-mitigation readings, and a recommendation for retest. That's primarily what we see going on, because the intention is to provide information to the occupant and the future occupant. Now, typically what they'll do is hang it on the pipe, assuming that the YouTube is visible. If it's not, like a new construction where nothing is visible, then it goes into the junk drawer. And these actual pressure field measurements, the things that you may take, are retained by the contractor for future use. Did that answer your question?
If I might chime in a little bit on this documentation note, I hope I'm not interrupting. But like I'm wet certified as well. I do like wood stove inspections and whatnot. And what they do is they provide a fillable PDF that's available to all certified people that they can use. They can insert their own logo, etc. It would be a good way to standardize the documentation part of things across the board for all people that are C-NRPP certified mitigators. Does that make sense?
Well, Brooks, let's expand that a little bit. So do you want to have, are you advocating that everybody has exactly the same documentation? Or are you saying we should start them out with something that's the same? And are you allowed to change it and add stuff? are you saying there's a core amount of information that we want everybody to apply, and then beyond that you can do extra, or does it have to be the same? What are you thinking?
I don't see any issue with being able to change it. But if there were a standardized form that was provided by the C-NRPP to all the certified people, it would give them a starting point anyways, and it would kind of level the playing field for certified people versus non-certified people. And it would say that this is the bare minimum that you need to do for every job. It works great. I use an iPad for mine, and you just pop it open, and it's just like this little checklist. You just go pop, 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 right? And then it's done, and then you can email it. Hopefully on site if you have an iPad that's able to do that. If not, wait till you get back home or wherever there's Wi-Fi.
Yeah, that sounds good. And actually, we were talking about that, right, Pam? We were discussing that a couple of weeks ago, and we're thinking there might be a need for that, to seed something out there and make it easy for people. Because some of the pushback that I was hearing anyways, because I'm a big fan of documentation, is that I don't have time for it. I don't want to spend 2 hours on the computer at night for every job, filling out these endless paperwork, right? That's not why I'm working with my hands. I want to get out there and do work. But actually, when you mentioned the iPad, you mentioned some forms, you mentioned some drop downs, right? I mean, you can see that's what I did. And the documentation can take a sum total of 5 or 6 minutes at the end of the job. While you're there, you hit export, PDF, email, it's done. There's no excuse for it to take 2 hours unless you want it to take 2 hours, of course. Anybody else doing something similar that Brooks was talking about? Does anyone else have a form like that they're filling out?
I could talk to that a bit as well, because I do have some wet certified guys that work for me, and I understand the form that Brooks uses. And Colin, to your point, what we've done is we've taken that wet certification form and we've improved upon it. So we still deliver the same base information, but we use software for our home inspectors that can include photos with our comments. So we like that more because we can kind of incorporate photos right into the comments. So we still provide the same for wet certification, what's necessary, but we go above and beyond. Like you said, I think there has to be that option for businesses to do what they want to do, but have that bare minimum. So I think it is a good point to have that, so that everyone's getting at least that minimum information, but then have the opportunity, as long as you're providing the right information and capturing that information, then you can deliver it in a different format to suit your business.
And how do people feel about documentation in general? I always try and push it, and I think it's a minimum thing we have to be doing, because it sets us apart. It provides more value in our work, because let's be frank, gluing pipe together is not difficult or valuable. And you could look at a lot of radon systems and say, oh, heck yeah, that thing in the corner, you did that and that was $3,000. Are you kidding me? That's the most expensive pipe gluing I've ever seen. Bruce is mentioning document controls liability. That's a good point, documentation. So I think to back up what we've done is to say, with documentation, is to say, it's not just that, that's the implementation of the thing I did, but the design and how I knew that was the thing to do is backed up partly by my documentation. There's a myth that's going around, the internet's been around for 100 years, and there's a bunch of different variants of this myth, but I'll just tell you one of them. Thomas Edison is having a problem with a generator in one of his factories. And he calls one of his frenemies, Westinghouse, to help troubleshoot this thing. And the guy comes over, he listens to the generators, and he's walking around, he's listening, and he takes a piece of chalk and he makes an X on the side of the generator. And he says, take that panel off right there. You got some windings that are shorted out in that generator and you should be fine. So, okay, great. So Thomas Edison goes there, he gets his guys, they pull the plate off, they look at the windings. Sure enough, there's a problem there. They fix the windings and they're awesome. He goes, that's fantastic. Thanks so much. Send me the bill. And bill comes back $10,000. And so Thomas Edison's furious. He's like, $10,000, you were here for like 20 minutes. I don't see what's going on here. And he's like, I want an itemized list of all of this invoice. So, okay, fine. He mails him an itemized invoice, and it said, marking an X on the generator, $1, knowing where to mark the X on the generator, $9,999. And I think that kind of describes a lot about our radon systems. They look so simple when they're done, but even where we put them, which fan we used, things we had to seal, things we took apart, HVAC we're balancing. It's all kind of invisible stuff that happens in the background. And if we don't document it, it's like it didn't happen, right? So I think we're making the invisible visible to some extent when we do documentation. Bruce had mentioned it controls our liability. Can you expand on that, Bruce? What are you specifically referring to, that if we didn't do documentation, how might we be liable for what happened? Are you muted? Maybe you stepped away. Okay, Bruce, when you get your mic going. Oh, he's shaking his head. Are you okay?
Well, Colin,
He's
it's
working on
Michael.
it. He's working. Go ahead, Michael.
Can you hear me now?
With my background being kind of like Bruce's, or is Bruce on now?
Bruce is on now. Let's let Bruce finish, and
Can you
then
hear me
we'll hear
now?
from Michael. Yeah, we can hear you. We can hear you now.
Yeah, as many of you know, I come from a consulting background, right? So a consultant is kind of like the guy from Thomas Edison, right? Why write? A consultant wouldn't write 2 lines when they can write 40 pages. But I always find that it's a balance. I have actually been in a situation, multiple situations, where my documentation managed to get a lawsuit dropped, and one that stopped Ministry of Labor from charging a client. And it's all because of diligent, consistent documentation. But it's a balance, right? So if you have a picture showing what you did, that's great, but the picture alone won't stand up in a court of law. There has to be some writing behind it. So if you have a document and you finish leaving the site with some preformed ideas, some preformed checklist organization, that these are the key things that I know as a professional I need to look at to make sure it was done properly. And if you ever get in front of any legal case, it's a lot better having that there, because the judge or the lawyers will look at it and say, well, okay, they thought about it. This was planned out before they went to site. They checked everything. They confirmed it was there. That's a quality job. That's following a process, as opposed to a contractor who I saw get ripped apart on site because he took his moisture meter measurements on the front of his folder. And I watched him get ripped to shreds on the stand. Very good guy, very competent in what he does, worst note taker ever, and I couldn't help him. And I just saw him just get crucified on the stand, and he wound up, unfortunately, having to pay a chunky sum of money. But as Michael's going to say, there's probably lots of consulting. So I think it's a balance between too much information and not enough. And if we can strike that difference, that's great. But also there is a significant difference between a residential job and a commercial job.
Okay,
right,
Michael,
on your level of documentation.
Fair enough. Yeah, of course. Michael, go ahead.
Yeah, I was going to jump in with Bruce having some mic issues and basically come across with the consulting side. And just, if you don't document it, it didn't happen. And if you ever get in front of a judge or have an issue come up, it's a lot harder to prove that you did what you said you did if you didn't write it down and didn't say it. Like in terms of the base information, CSA for that's consulting types in the environmental field, they proscribe what we're supposed to cover in a phase 1. But it doesn't mean you can't modify, adjust, make your own style on it and add your own value added to it. So, having a base amount of information doesn't necessarily mean it's a bad thing. It doesn't stymie the ability of contractors and mitigators to have their own spin on it, have their own style, have their own piece that they add on and add value to. But, it's all documentation. It's ways to prove that you've done your due diligence and that you're covering yourself, and that it helps prove that we're doing what we're supposed to do and we're doing it well, not just I'm going to open up a hole, throw a pipe here, put a fan on it, and you're going to be fine. Yeah, not a problem. But when you can say, okay, well, I've done my measurements across the slab. I know I've designed the system, I've sized the fan for it. I'm not putting in a big 4 on there if I can get away with a 1, or things like that. It just proves that we're doing the job right and responsibly and being the best we can. So
I think so. You know, in my example there, I showed what the base environmental conditions were during my visit, and I showed how I came up with a target pressure that I need to demonstrate to prove that I fixed it. And then I fixed it, and I documented that I fixed it, but here's the pressures that we saw. I don't know if they show up in the same order, and I'm just getting the hang of this Zoom thing, but I see Kurt's got his hand up, so does Robert, so does Doug, and I'm hoping it puts you in the same order that you started. So go ahead, Kurt, you have something to add.
Can you hear me?
We can hear you, go ahead.
So one of the things that's been mentioned, but hasn't been, I think, drilled into enough is that your documentation is part of a strategic choice for your business, depending on what you're trying to do. And people have been making a lot of good points, but I want to focus on the marketing piece of that. If
Okay.
your business is going to be differentiating from other mitigators, or in my case, consultants, you have to choose if you're going to have investments in that differentiation. So for C5 Plus, for example, our reporting and communication is a key differentiator in the industry. We provide better information to our clients. We don't have normal marketing. Our marketing material is our previous work. And that's kind of what I'm hearing talked about from you, Colin. Jeff touched on that. So if you're a mitigator, you want to decide as a business strategy for marketing, how much you're willing to invest in coming up with that system. So yeah, there has to be a baseline, but you should consider this as a possible marketing advantage, specifically 100%. As part of your marketing plan and your overall strategy.
100% agree with you. I tell my guys, you know, like we're not leaving early. We're staying till at least 3 o'clock every day, no question, doing solid work. We do documentation. And they always roll their eyes at, they don't always, I'm exaggerating. I can get the eye roll once in a while when I'm doing something they feel is over the top or unnecessary. But I remind them, I'm keeping you employed. We're not doing this for this job. We've already got this job. I can do a crappy job here and get paid the same amount of money. We're doing this for the next job because we're going to get the neighbor's place, the other neighbor's place, their brother's place, and their sister's place across town. We're getting all the places as a result of the documentation, of the due diligence, of the of hiring us to do the work. So you're right. It's for the next job. Robert, go ahead. And Doug, you've got your hand up, but you just chime in. Eric, you too. You guys are the guests here. You guys are the experts. You just chime in, over talk, no problem. You're in. But Robert, go ahead. Say what you're going to say.
Yeah, I couldn't agree more with Bruce. He touched on the legal issue. Yesterday we had the legal talk about you put new windows in and you increase the radon. I'm also being hired by lawyers as an expert witness, and we're becoming like the United States in suing. You can sue anybody. I've seen somebody being sued for something he didn't even do. It cost him $30,000 to defend himself. I've been in court cases, and I provided the judge up there. He has no idea about radon or progenies or polonium or whatever, and he actually stopped me. He said, I needed 10% evidence. You're giving me 300%. Stop talking, stop documenting, stop everything. Case closed, and everybody was happy. So and it sounds maybe crazy, but the more you document, the more credible you are, and the more beef you have. If anything goes to court, you say, oh, no, look at this page 3-1.
Yeah, residential mitigation, I don't know, we're dealing with court as often as you guys would. But what I'm noticing here, and probably others as well, is that the consultants here are the ones first stepping up to defend documentation, right? You consultants are the professionals. Oftentimes you're engineers, you have special training, you're doing high value jobs. You guys are the ones speaking up in favor of documentation. And we're not seeing that so much from the mitigator guys. But I think it's just showing us that this documentation is trying to raise our game to the next level of professionalism. And I think we need to challenge ourselves as mitigators to say, we're not just people gluing stuff together. We're scientists, we're building scientists, we're radon professionals, we're certified, and we got to up our game and produce some documentation because that's what's expected of this level of professionalism. Hey, Doug, go ahead.
Yeah, I was just going to add from perspective down here and experience. What Kurt said about your documentation being a marketing tool is absolutely dead on. Down here, at least my experience has been, the best advertising is word of mouth from one client to the next, especially if you get into commercial work. And a really slick looking package of documentation is one of those things that sets you apart from the other. And quite frankly, over the last 30 years, my marketing budget has been like zero. It's all comes from word of mouth and the documentation. The second thing I'll caution you on in coming up with a form, you're kind of constrained to that form if it's only dealing with active soil depressurization. Because you'll get involved, I would assume, in commercial buildings where there's an HVAC system that has an impact on what you did, that those conditions that are extraneous to just the ASD system, or maybe it's a total ventilation approach, needs to be included in that documentation. So I would suggest, you know, what you may do is come up with the minimum pieces of information and then allow the contractor to generate their own internal forms based upon what they do and allow them to amend it. That's all.
Yeah. So maybe instead of prescribing something, you must do this way and this way only, we have to have room for flexibility and room for all the different types of radon mitigation approaches, not just subslab depressurization. Yeah, I don't think anyone's in favor of forcing us to do one thing. So I think that's a really good point on that. I think the concept that we're floating is, what if we seeded something out there? What if we just started the conversation? We start with your basic subslab depressurization system, give some suggested documentation, make it easy for them. They can use it, they can take it or leave it, but it gets them a head start. It's a little push in the right direction, as opposed to prescriptive, thou shalt do this. Because there's lots of jobs where I can't even follow my own rules. If I had rigid rules, I couldn't do them. We in Canada, our approach is that we depressurize the entire footprint. That's the only approach. We have no other multiple approaches. It can't always be done. Sometimes we have subslab ducting, and we have to pick a region where we feel there's high rate on entry points and work an intervention in that area only. That wouldn't fit in our current documentation. So I think your point about flexibility.
You want it to be an aid rather than a constraint to innovation.
Okay, that sounds great. Bruce, one thing, and then John. Bruce, go ahead. You're muted.
One thing. That was Doug touched on it, and so did you, with modifying what you can write. You're right, Colin. If you can't get the job perfect and it can't meet it, it's also important to document our mistakes, so to speak, but also why we would not hit that top mark. So
Amen.
You might not get the pressure field.
You are so dead on right there. I have to jump in. I'm bursting.
Yeah.
That is when documentation is the most important.
Yeah,
I have had jobs where the ones I can't do right are by the book. I have to document. I bring the customers in intentionally, and I don't just hope it works and hope I never hear from them again. I say, look, I've got a problem. I'm trying to accomplish this pressure. I can't do it. Right? There's no fan in existence. You've got a finished marble floor. We have to start the discussion about why I'm having trouble, what I've done to make it as good as it could be, and how the future phases could unfold and what those phases could look like. And the documentation and the interaction with the customer is critical at that stage.
Yes,
that is when that's when it's worth its gold. Awesome.
Because you've documented your rationale as to why, and you've made some reasonable causes. Or sort of reasonable conclusions, and that will protect you in law. And I've seen Ministry of Labor people crucify people because on their inspections they never find any mistakes. And if on your routine inspections and your routine documentation you never have any mistakes in your job, the judge or the legal department clearly looks at that as you're lying, because no job goes perfectly, and that's exactly how they will take it. And there is a huge difference between tort law and breach of contract. And if we're dealing with a cancer-causing agent in someone's home and we get into tort law, we want to be protected because there's no limit to tort charges, right?
Okay, good
Homeowner
point.
can sue you for $50 billion if they want.
All right, thank you for that. John Costello, this is the first mitigator perspective here. John, what do you have to say? Unmute yourself and you're on. You're muted. I don't know if you're trying to unmute yourself or you're there, but your video is not on and you are muted. Put your hands up. Okay, well, while John's figuring that out, that's great. What a great discussion on that. I just want to let you know that it's come up.
I want to chime in one more thing here, just as an example of another use of documentation. 2 weeks ago, I was asked into a school that had a radon concern. And We were going to go through the whole diagnostics, very large high school, very complex. And then I looked at the drawings and realized that 30 years ago, they had installed a passive radon system, and the current owners were not aware of it, or at least current managers. Having that documentation of prominent labeling would have helped. Fortunately, we did discover it. All we needed to do is put fans on the passive system and problem gone. But without that kind of information, they would have spent well over $100,000 in fixing that school.
There you go. So documentation is helping you in the road or helping someone else down the road. That makes a lot of sense. Okay, that's fantastic. Great. Anyone else with anything on documentation? I just want to let you know the topic has come up. We are actively talking about working it. Does that make sense? Actively talking about work. I don't want to tell you we're actively doing it. We're having active discussions right now and doing exactly what you're saying, providing a minimum level of documentation on an iPad app to make it easy for you to do this documentation in the field. So look forward to that. And if you've got something that you're already using, you want to share that everyone can use, then get in touch with Pam, myself, and let's make it happen. I think we've come to a clear point in our certification process where we need to start standardizing some stuff, or that's not the right word, seeding best practices and making it easy to build on yourself to differentiate. So you still have the ability to differentiate yourself.
Jump in a couple of points on this. So we have a couple methods that we've been working on. It's been a long process because we're trying to get agreement on a number of things. We're trying to align with the CGSB standard, but also have it consistent. So we do want flexibility, but another note in the flexibility is that there should be some consistency so that if a homeowner goes from house to house, they don't have to figure out this document again, so that we can have some, communication to help the homeowner interpret your document or be able to talk to them about the document. Also, we're going to require it to be submitted to C-NRPP. And so we're just in discussions about how much. For one, if you ever are come under a discipline, so if somebody submits a complaint about you, documentation is going to be our first thing we ask for. So you're going to have to submit documentation on it. Renewals, now we're going to start to ask for at least a sample of some of the documentation that you're requiring, because it's a requirement in the CGSB standard. We want to see what's going on. So that will be part of the renewal process for at least some of your mitigation hands-on credits. And so we are developing an app. We're looking at a couple different things. One is a really economically priced app that you can just share the form and be able to kind of use it on an iOS device, either an iPad or an iPhone. And then we also are looking at developing an app. It would be a more costly feature, but something that maybe you would charge the homeowner, a $2 fee or something, and that would go right to the app so that we continually develop and keep it updated. And we may include like a permit on there so that they could call us if they're having problems with the system, and we can kind of go in and take a look at it as well. So we're looking at also that as a kind of a permit option, but it is something that we're taking seriously. And a note on Barry had brought up the idea about the fan energy use, which is something that's required in the CGSB standard. It has been something that's been commented before. It's hard to figure that out because it's different prices across the country. So if you're jumping from jurisdiction to jurisdiction, plus it changes. So we're looking at some of that change. And the last point on the liability of doing something different, that is really important to document, because if you say, oh, I'm using this standard to install, and you don't document everything in your step, but at least it's in the standard and you can show that you followed the standard in your installation, but you violate or you do something different from the standard, that's when you need to document to say, okay, this is, I followed the standard up to the point, and then this is why I did something different. So you do need to make sure that you're documenting those changes from the standards.
Yeah, I'll work with you too. And I'm going to make sure that we're not handcuffing people into a rigid, documentation process that doesn't fit all solutions. It has to fit everything, including I had to just do this one thing and hope and cross my fingers and hope that it works. It has to also accomplish that as well. But of course, you'd have to document why you couldn't do the other approach. I think it's fine. That's fantastic. Okay, well, if there's no one else on, you had your hand up earlier. Go ahead.
One comment, Colin. And for everyone, I think it's like a lot of the documentation we're talking about is quantitative, where it's basically, we're putting down numbers, yes, no, check boxes. And then you talked about that point with Bruce about when you have problem jobs, you want to document even more. I would say almost every job, it's nice to do just a kind of a free text documentation or even a video, just explaining what this job was about, so that if you do have to go back to that job, you've done 40 jobs since then, it's 3 years ago, and you can put yourself back there as, kind of pick up where you left off, start using the same line of wording with the homeowner that you used when you were there 3 years ago. Because sometimes just looking at those numbers and looking at the empirical stuff, you can't really figure out exactly what was going on there. Whereas a couple lines of text or a short video, you can see, even if it was an easy job, there might be one or two things that were on the back of your mind that you're like, well, if things weren't working perfectly here, here's where I'd look next. And so you don't have to start fresh if and when you go back.
Yeah. Maybe Pam, we could put up a poll here. It's probably not something you can do at the spur of the moment, but let's get a poll ready. And let's ask the question, how many people are producing documentation on every job? Let's do that for a poll, okay? Because let's see how big of a problem this is. And by documentation, let's not say fan labeling or the booklet that came with the radon fan, because there's no information in there. Something you actually send to the customer that describes your design, what pressures you were trying to achieve, and whether or not you achieve them. Let's put a poll out for that, okay? And that might help us to determine if this is a problem worth solving. And I think it is. I think it's not something that's widely done, but let's find out. Okay, great. Let's move on to another topic, although we can bounce back to this one. What else is on your mind? Thanks for that one, Graham. I think that was a great topic to start out with. Anyone else have the next topic we want to jump onto? I'm going to put the gallery on here. Let's see who's in the. Anyone else have something that's on their mind? Tools, techniques. Bob's got something. Bob, what do you want to talk about? Okay, Bob, you're on. What do you want to talk about? You're muted. You're muted. While Bob's unmuting, let's put our heads to the next topic we're going to be talking about as well. Concrete, that is, it's Tom. This is Tom Weber. Tom, are you suggesting, hey, Tom, I see there, concrete that itself has high radon levels. Is that something you want to talk about? Emanation, building materials.
Yeah. I ran into a project that we did everything. We run in double fans. We did run into grade beams. We went underneath the beams. We added extra fans. We did everything possible to get it down below 200. And finally I said, I keep all the plugs. When we cut cores, I keep all the plugs so the job is all done. And I said, what the heck? Let's just test the plug.
Right.
So I brought it in and put it in turned the steel pail upside down and put my radon eye in with it. And I ran it for over a month. And only 2 or 3 days of that month, it was under 200 becquerel. So the concrete itself was high. So really it comes down to the only thing we could do was actually cover all the concrete with a skin. And well, that wasn't possible because it was a finished basement. So we kind of explained the situation to them, and we got it down as low as we can. And we can't go any lower without doing some major work in their basement.
Well, I think Doug's going to have something to say about this one, because you said something that was interesting. You said you had it in a steel pail. I'd like to know, and I don't know if you said upside down a steel pail, but I want to know what surface you put it on.
Yeah.
And also you said only a couple days in the month, it went below 200.
Yeah. I actually tried 2 different ones. I did a plastic pail and a steel pail on a steel surface. I actually put it on the top of a filing cabinet. Is what I did instead of on a concrete floor, because the concrete floor in my shop would taint the actual measurement I'm getting from that. So I wanted to make a separation between the two. That's why I used a filing cabinet.
Right. And what's the radon levels in your building that you're testing it in?
Actually, I got it running in here right now, and it's 21.
Yeah, because radon emanation, I'm gonna let Doug take this from here, but radon emanation is a consistent process that doesn't change over time. So when you said it was going down a couple times a month below 200, that made me wonder if maybe that pail's not sealed or if it was getting something from below, because my understanding would be that emanation rate would be consistent and we would have the same levels in that bucket if it was indeed sealed. But I'm getting out of my depth here. Doug, what do you think about that? What Tom was talking about?
Well, emanation can be a concern in specific, at least down here in the States, some specific areas where they have high phosphate materials that have gone into concrete in Florida. We've also seen some skim coatings used in Japan. The way I always suggest that people test for this is to get 2 continuous radon monitors. Put one in the room and then another one on the slab with a sheet of plastic over the top of it, well taped down to the surface, and choose a spot that doesn't have a crack in it, in that concrete. And you start them up essentially at the same time. And what you'll see is the room concentration doing its normal thing. And if there's an emanation source, you'll see the radon ramp up. In about 24 hours, it hits a plateau. And you compare that measurement to what's going on in the room. And what you'll see, if it really is an emanation situation, it'll climb up to, sometimes, 500, 600, 1,000 picocuries per liter, which multiplied by 37, that's a lot, becquerels per cubic meter. The other way to do that, well, let me back up. And then once you have that, you look at the slope of the line as it's going up, as it's increasing. So many becquerels per cubic meter per hour, per minute, whatever, but it's a slope of the line. You measure the surface that you have the poly on, the sample that you're testing. So you get so many square meters of that, and then look at the amount of that material that's in the room or the building. And then there's a calculation. That's one of the spreadsheets we actually provide in one of the courses, based upon the ventilation rate of the building, square footage of the material, and you can estimate what the radon contribution is. So that method is kind of quick and dirty. You can tell within a day whether it's an issue. But taking a plug of it and putting it in a bucket, there's a lot of things going on that are not replicated in the building because you're concerned about what's emanating off the surface, not the sides of the core that you pulled out. The only other way to do that would be to take that core and put it in like a charcoal canister and solder the edges of this and let it set for a month to let the radium come into equilibrium with the radon, then measure the activity off of this. But that's still kind of artificial. My feeling is the best way to do it is what I just mentioned. So you're actually measuring what's coming off the surface of the concrete. Secondly, as far as mitigating it, coatings are not necessarily the answer. When you have an emanation source, I guess one way is to remove it. In fact, that's what they did in the late 1970s through the western slope of Colorado, where they had uranium mill tailings used as construction materials. They actually tore up foundations. But the typical way of dealing with it now is increasing the ventilation to that building with heat recovery ventilators. If it's a commercial building or a school, which we ran into a Department of Defense school, the whole building was hot. We had to increase the ventilation rate in that building, which was not too tough because they had fresh air makeup. But then you also need to be concerned about what gamma may be coming off of that same material. If it's really a hot material, you've got gamma concerns. And that's where the coating won't help you, neither will ventilation. But generally, you go back to ventilation as the approach. Yeah. And I guess one other example is a student called me from South Carolina, where they had tested an apartment building. They wanted him to put in an active soil depressurization system. And he said, if I do that and I core through the slab of the first floor apartment, I'll be looking down into the open air parking garage. There was no soil contact whatsoever. Everything was coming from the building materials. Unfortunately, it wasn't that elevated. It was like, 4 or 5 picocuries just above the guidance down here. So just a little ventilation did it. Or in some cases, we'll back up and look at radon decay product reduction through air cleaners and just a ventilation air movement within the building. So that was a long-winded answer to your question. I'll be quiet.
Yeah, I think I have the same issue in my house, actually. I have a lot amount of concrete in my building, maybe 130 cubic meters of concrete in my house. It's all concrete. All the floors are concrete. All the walls are concrete. It's all concrete. And it doesn't make a huge difference to me, but it makes it difficult for me to get my levels below 50 becquerels. I definitely require HRV in order to get that down, even though I've got tremendous subslab depressurization. So I have the same problem on a much smaller scale. So that's a good point. Well, Doug, one last thing. Tom mentioned that the radon in his bucket with the radon eye only dropped down below 200 a couple times. To me, that indicates that the bucket's not sealing necessarily, and it's spilling all the time, because it should be constant, right? When it reaches equilibrium, it's a pretty flat number, is it not?
Exactly. It'll go up and then plateau out, because the time at which it's breaking down into the decay products equals the concentration that it's in equilibrium with. So I would suggest or suspect that there was some leakage of air going in there. And the same thing in a house. If in Florida, which is known for this problem, where they have really tight apartment condos right on the beach, there's like no air exchange. They have contaminated building materials and so forth, but you'll still see a variation because the leakage through the shell will vary as a function of people opening windows and doing things like that. So it's typically additional amount of air that comes in to decrease it. Once that air entry has been stopped for some reason, it comes back up to that plateau. And it typically takes about 4 hours for it to equilibrate after there's been a change, inside that bucket.
Like I still got all the plugs here. I'm gonna retest it and do a couple of things a little differently, and just as an experiment for myself. See what happens, see where it goes.
Yeah, Tom, keep us informed here. Here's what I want you to do. I want you to take some plumbing putty and seal around the edges of your bucket to the top of your metal filing cabinet, so there's no air leakage whatsoever, okay? Reset your device, and if we're gonna determine the emanation rate from that core, Doug says we need the slope of that line. So capture that data, put your radon on there and capture that hourly data, and if you send it to me or Doug, or if you can do it yourself, we're gonna determine the emanation rate, and in your case, it's gonna be per kilogram. We're gonna have to weigh it, I guess, would be the best way to do.
And get the surface area too. And I think, Tom, what Colin is saying, there's a hole in your bucket, dear Tom. There's a hole in your bucket.
Yeah, that's right. Because the radon levels should be very consistent. Anyone else have an emanation issue that they want to know about, or building materials, suspected building materials? Would it be useful to have a course on how to determine, I see you, Brooks, waving there, on how to determine the radon flux from a material? Would that be of use to anyone?
What I was going to suggest, Colin, was that I think one of Doug's courses, I think it was in Vancouver, he was talking about dealing with the daughter products in situations where, okay, we can't actually deal with the actual radon because of one thing or another. And I think he was talking about MERV 14 filters on furnaces, other stuff like that. So like maybe filtration, trying to get the actual working levels down versus trying to get the radon down. Just a reminder for that.
Yeah, I think Doug was putting up his hands there. He wasn't saying stop. I think he was saying MERV 10. Now, is there an advantage to going to a MERV 11, 12, 13? We hear about for coronavirus, MERV 13 is the way to go. Increasing the MERV value, did that reduce the radon decay products, or is 10 all you need to do?
I've done a lot of measurements on this, and when you've got an air cleaner or a higher filter within your air handling system, assuming that the air handler is running all the time, truth be known that just the air circulation reduces the equilibrium factor, and hence reduces the daughter products in the air because they attach to the inside of the duct. Canada, we assume 40% equilibrium, in buildings where they are constantly recirculating, I see typically 20%. And then when they go in with a better filter, and MERV 8, MERV 10 works just fine, because the decay products or the dust to which they're attached are knocked down very, very easily. If you go to an extremely high filter, like a true HEPA filter, what can happen is it's so good at knocking it down, you no longer have dust particles to which the daughters can attach. And per unit exposure, it goes up a little bit at the extremely small particle size. So I always specify MERV 8, MERV 10 filters, not a MERV 14. And what you said is correct. We're certainly seeing that down here, where a lot of people are putting in better filters in their air handling systems or unitized filters. They have a dramatic impact on the daughters present. And we would not draw to that technology Typically, we do active solid depressurization, but there are instances, and Tom may have brought up one, where you've got building materials or just, a very difficult mitigation that you step back and look at that and ask yourself, what are we trying to do? We're trying to reduce the exposure. And reduction of radon reduces the exposure, but even more so, reduction of the decay products reduces the actual exposure. So I would not go to the high MERVs. It's something to draw to after ASD, or maybe reducing, levels further. We have people who ask us, can you get it down equal to ambient or better than ambient? And the answer is, with that technique, in addition to ASD, yeah, we've been able to get it down to less than ambient.
Now, you mentioned something there that I really clued in on there, Doug. And you inferred that the unattached fraction that you might see go through the MERV 6 HEPA filter, and you said the exposure goes up again. Is that science settled? Because I know that's a hot topic, right? And people talk about the unattached fraction, but I've never seen any documentation in the norm guidance or the ICRP stuff that talks about the unattached fraction. Is this science settled, or is this just conjecture? Or how do you feel about that unattached fraction argument you made?
Okay, let's back up and clarify something you said. It's not that the smaller particles are getting to the filter, through the filter, because the unattached fraction, polonium-218 and 214 are extremely diffusive. They'll move laterally, stick to the wall. The higher amount of unattached fraction occurs because you still have radon coming into the room that's breaking down, creating decay products that have not made it to the filter. That's why that's why the unattached fraction goes up. But overall, the dosage is reduced. It's when you get down to like 1 nanometer or less that the risk starts to go up a little bit, but it still doesn't get back to where it was before. So in the case of reducing radon, the risk reduction is linear all the way down. When you deal with reducing radon decay products, it's not exactly linear. It goes down like this, then up a little bit, but nonetheless, it's a reduction. And the other thing is, when you look at air handlers as they're turning air over in the building, the recirculation rate may be 2 volumes per hour. That's typically what we call out, that you're never allowing the radon to break down into enough decay products that are not knocked out by the filter. That's how you overcome that.
Okay, good to know. Great, thank you for that clarification. Okay, Kurt, one thing, and then we should think of another topic. Someone think of another topic. Go ahead, Kurt.
So I would never disagree with Doug, because I know I wouldn't survive the argument. But this is my business. Not the radon part of this. I agreed with everything you just said. But there are other factors in play in terms of human health and safety here. Number one, and I think we both agree on this, is the increased ventilation should trump the filtration, generally speaking.
Yeah.
And mostly because I think of the played out effect, right? The more you got it flowing through these, especially big commercial buildings, they're going to play out like crazy. But the other thing I really wanted to point out is, be careful about only thinking about radon as a hazard. Yes, we're a radon group. There are plenty of other health hazards, and we need increased ventilation, not just for COVID-19. We've known this for 20 some years. The more ventilation you provide, good, fresh outdoor ventilation, the healthier your building occupants are going to be. So you don't want to be making people, so the MERV 10, MERV 8 may be fine for radon. It's not fine for other things in a building. So there's a trade-off there, and good luck quantifying that, by the way.
What's your recommendation?
I agree with you totally, in that there's no reason not to go to the higher MERV for other reasons, but we don't have to go to.
Well, right now, MERV 13 is the compromise more or less agreed upon with respect to COVID-19. We're actually seeing MERV 15 equivalents because I work with large commercial buildings primarily, because we're doing MERV 13 coming into the building and MERV 13 on the compartment fans onto the floors. And we get a de facto effect of MERV 15 plus, which is spectacular. You can't do that in a house typically. don't even think about it.
No.
So
Well, that's why the house, in order to keep from starving your air handler, you have to go to a MERV 8, MERV 10 deep pleated filter so you don't have a high drag on the filter.
as usual, I just agree with Doug. So
You disagree with me? Okay.
no, I agree. I agree.
Okay. Well, in those here, Kurt, I challenge you. Colin's making challenges. In those buildings you talk about where you're using the MERV 15 for inlet as well as in the cabinet, whatever, measure the decay products. I know you have the capability to do it.
I have the capability. I don't have the permission of the owner.
Cop out. Okay. You got a hole in your bucket too.
Once again, I'm forced to agree with Doug.
Okay, great. We got a couple other things in the comments. I'd like it if you guys could, if you can, unmute and put your suggestions for the next topics forward. It's better for me because I'm going to skip these ones. But Pam reminds me there's some stuff here in the comments. Peter Fleming's asking, are there standards to ensure building materials be radon free? No, I don't think so, Peter. But what you reminded me of when we were in Switzerland at a radon conference a couple of years ago is, does anyone here know what the radon rough-in requirements are in Germany offhand? No? Well, here's what I think they are. It was you have to use poly, and the gravel under the slab can't have any more than 300 becquerels per kilogram. That's their radon rough-in. So they're making sure they're not importing a radon problem. When we have this granular porous layer under the slab that is now letting radon travel very easily anywhere under that slab and through defects in the poly or into the building, it makes sense that that gravel shouldn't be an additional source. In some cases, maybe it is the source and the native ground is not the source. So Peter, I think in Europe, they're thinking about at least the gravel. Maybe I had heard they were testing gravel for radon in concrete in Alberta, but I'm kind of skeptical of that. So I don't think there are standards. If anyone knows differently, let us know. I think you can put as much radon into materials as you want at the moment. Pam's reminding me we are halfway through. And another topic in the chats is dealing with customer complaints. Hopefully you never get customer complaints. The idea is that your documentation, your thoroughness, your expertise, all that stuff ends up minimizing the number of customer complaints you have. If you have a lot of customer complaints, I think you're probably going to want to look back at your own processes because you're probably causing those to begin with. But having said that, customers, there's not all reasonable customers and they can complain about anything. The documentation would back you up because you'll say, this is what I needed to do. This is what I did. Therefore, I've done my job. Maybe it's customer expectations. Were they expecting the radon to go down to 0? When I talk to the customers on a site and I'm walking them through, I'm telling them what we're going to do. Sometimes they do, mention somehow that they're looking forward to seeing 0 radon in their building. So sometimes maybe we have to set the expectation of what a successful mitigation might look like. Maybe in your warranty you have, it's going to be below 100, below 200, below 50, whatever your number is, as low as reasonably practical. So maybe we could look closer at what types of problems people are having, what types of complaints they're having, and they may be related to customer expectations. Or are you referring to noise issues? Is it a noisy system? We can fix noise with the appropriate fan, number one, with mufflers on the airflow, with vibration dampening to the structure. What are the complaints that you're getting? What are the types of complaints that you're getting? I think if you told us that, I think we'd be able to help you out and find the source of them. So maybe chime back in if you can, or unmute, or go back in the chat and let us know what types of customers, what are they complaining about? That's a big problem, and I think we can help you solve that. All right.
I have one, Barry.
Thanks. Barry, what have you got?
I find a lot of times when here in the area that I work in, I run into really stiff soil all the time. So I guess the probably incorrect assumption is let's put the biggest frickin' fan in there that I can get because I'm not getting any good results. And what I find is I put it in RN3 and then I have to go back and change it out with something smaller because the RN3 is just sucking so hard and there's no air moving that fan freewheels and makes howling noises. And so that's what I don't know if anybody else is having that issue.
Yeah, the old howl, right. Well, the Health Canada process just says, hey, we got to depressurize the entire footprint. And you're saying my soil is so tight, I can't depressurize the whole footprint, so I'm going with bigger fans. One thing I want to mention, I was on a webinar one time from OBAR Systems in the States, and those guys are pretty smart guys and do a lot of VOC work. And they had a presentation where they demonstrated that when you don't have any communication, sucking harder doesn't help you. It barely makes a difference. So that's kind of a misconception that we do. I think a lot of people fall into, that a bigger fan must be better. Now, remember from your training that the pressure extension at the far end or at your communication hole is a linear function of airflow at the suction point. So if I have 2 pascals of pressure change right now, and I'm moving 100 CFM, if I move 200 CFM, I'm expecting to get 4 pascals over there. That's one of the fundamental relationships that are mostly true from our work and residential work. But if you have 0, 2 times 0 is 0. So that's why oftentimes we don't get a lot of pressure field extension difference just by sucking harder. So typically we have to do another technique like gophering, like multiple suction points, tunneling. We have to do something else to expose more of the slab to our vacuum, because sucking harder doesn't often do much more. And you're experiencing that. Lance is coming in here. Thanks, Lance. If you can locate your suction point close to the weeping towel system, you can make a huge difference in fan size. And that's absolutely right. And as probably everybody knows, plumbing is a big one, right? If there's plumbing down there, get next to that plumbing, and you'll often find yourself this conduit that's going to take your pressure, at least some kind of difference. I had heard, in the community in Hoover, Rob Mahoney was hitting the slab with a hammer to find a hollow spot. I don't know if that works, but I get that. Doug's giving us a thumbs up. Well, tell us more about that, Doug. Does that really work, and how do we employ that? What sophisticated specialized equipment do we need to perform that test?
It's called a 2-pound or larger rubber dead blow hammer. And you're tapping around and you listening to it as you hit the concrete. When you hear that hollow sound like a bass drum, that's where you want to put your suction point if you can. Because applying your suction point where it's really solid and tight doesn't do you a lot of good, because where it's coming in is where it's probably hollow. So yeah, when we were doing a bunch of houses, these are military installations, that was my diagnostic tool. Bam, 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 put it here, move on to the next one. It really does work. Or if you don't have a rubber mallet, a boat oar works pretty too. Just drop it and let it listen to the sound as it hits in the concrete. You can identify grade beams as well with that technique.
Sorry, what were you dropping? You said you were dropping something if you didn't have a hammer. What was that?
A boat oar, a canoe paddle.
Oh, canoe paddle. Okay, I got you. Okay. Maybe we can make a special tool that sounds differently when it's hitting something. So
rubber mallet. In fact, after we were done with that particular project, the housing manager, the colonel, had a big community meeting, and someone stood up and said, "How much are you paying these guys to come in and pound on my slab?" They thought it was pretty nuts, but it works.
So basically, this sounds like the modern, maybe this mythology of the Westinghouse Thomas Edison thing. We can now say it's a rubber hammer and it's a mitigator.
Yeah, rubber hammer, bump, bump, bump. And you may not be able to put it there because it's a finished space, but in the unfinished spaces, if you have a choice, hit the hollow spot, because that's where it's going to be easier to dig, and chances are that's where one of your entry points are. And
maybe you can gopher over to that hole or connect it up to that flat spot somehow from a suitable suction location. Does that, Colin, does everybody know what you mean by gophering? Yeah, most people do. Gophering is when we drill multiple holes in the slab, typically up to 4 or 5 feet apart, and then we tunnel between those holes by hand in order to connect them. So instead of sucking from a single point source suction point, we're actually sucking out from a linear tunnel that's actually underneath the slab that dramatically improves our odds of hitting one of those more permeable areas you're talking about. We should also mention dead blow hammer. If you're not a woodworker, you may not realize dead blow hammer is a rubber hammer, a plastic faced hammer typically, that has beads inside, steel weights. So when you hammer down, you don't get that bounce. It goes straight down, transfers all its energy down, and you find that makes a better sound than just a normal bouncy rubber hammer. Yeah. Okay, he's got a thumbs up. Okay, yes. Great. Yes, there we go. Greg Zapperzan has a complicated question for Doug. I don't know if you can see the chat there, Doug. You take a look at that one while we're looking at the next issue. Okay, another topic. This is really good. You guys are on fire. What do you want to know? What do you need to know before you leave here? Because the time is 10:47 and we are going to turn into a pumpkin at 11:30. So what is most on your mind? Lance, I noticed you have this giant white hand beside your picture. Do you have your hand up or is that just your icon? No, he doesn't know. Maybe is it me? No, maybe it's me. It's me. My icon turns into a giant hand and it's been sitting over your picture the whole time. Well, having said that, Lance, have you got a question? Do you have anything you want to talk about? What's on your mind? What can we help you with? You're perfect. Maybe you should be telling us what we should do. Come on, there's got to be something. Anything? Nothing. Okay, well, you think of something. Okay. Anybody else got something? Graham Green, you're quiet down there in the corner. What's new with you up in Edmonton? What have you been finding? Give us something. Give us something to talk about.
Who has ever used a U meter?
What kind of meter?
The U meter. The U meter that we have to put by law on the.
Yeah, perfect. I think that's a great topic to bring up is the value of the YouTube manometer. Is that what you're asking?
YouTube, yeah.
Yeah. So
yeah, I questioning that. I find that this part of the specs or the code or whatever you standards is counterproductive. I like to have things that are homogeneous in strengths, and that is I'm condemning my work, my nice work, to be can be hooked by a hockey bar or whatever is happening in this basement. So that's something that is on my mind. If you ask, there is also something else that is in my mind that is more on a theoretical way, because I'm also a home inspector. So when I see there is a vapor barrier in the ceiling, I can say there is appearance of a vapor barrier, but I don't know if this vapor barrier is constant, is continuous, or if it's just discontinuous. So the same with the whole test that we do in a slab, and we do the communication test, and we imply that the whole slab is providing this radon from everywhere, whereas it's just a pure fictive notion of what's happening under there. And if it was happening, we would get the zero that the client is sometimes expecting. If we don't get the zero, that means that this model, which works great, is just a theoretical model, and the reality is that it is not spraying from the earth in an even place. So I have other things, but.
Well, you said a few things there. Maybe I'll let Eric talk about the YouTube, but you were talking about the communication holes, I think, and the fact that we make an assumption of those pressures based on our measurements at a communication hole. That's absolutely true. And this is where your judgment and your skill comes in, because you need to put as many communication holes in that slab as is necessary for you to demonstrate that you've got everything. Now, in many houses that are very small, good gravel, clean poly, maybe it's one hole, maybe it's one hole diagonal. And if you can get way back to the other side, you can infer that you've got everything else. But maybe your soil is not so cooperative and it's difficult soil, it's tight, it's dishomogeneous, and you need to put in more. I put in as many as 9 communication holes to demonstrate to myself that I've got everything, and I've done as little as 1. But you'll never get zero radon, of course, because it's not zero outside, and the air that's in your house comes from outside. So we're going to see 10 to 15 in most areas of Canada as a lower level. And if you went down to the States, it's even different. I was speaking to Bill Broadhead the other day, and there's times when it's 10 picocuries, right? What is that? Almost 350 or something? 370 becquerels, obviously. Outside. So you can't get the house lower than that because of that thing. So we'll never get zero, but we do want to get as close to zero as possible, or as close to, let's call it outdoor levels. That's what's kind of achievable, is what you're saying. So the number of holes you have to put in is the number that you need to feel will demonstrate that you've done the whole slab. And that's not necessarily 1 or 2, could be 10. Eric, do you want to comment on the YouTube?
Yeah, I think, I don't know if what you're saying, Gene, is that it maybe doesn't seem like it should be a requirement on, or you question its value in being a requirement on systems. Is that a correct understanding of what you're saying? Yeah, and I
Yes.
agree too. I kind of feel like prior to having different methods of analyzing or monitoring the effectiveness of systems, it was the only thing that we could really do. But I think now, my opinion anyways, is that that provides just one tidbit of information where there's maybe 10 different things that would be interesting to know, and we just provide them the one. And in a lot of low flow, low static systems, it actually tells people nothing. And so I find that it causes a considerable more confusion than it does value to the client.
Yeah, but there is a requirement in the CGSB standard for what they call a performance indicator. Now, it's a YouTube because they're robust, they're filled with oil, they don't evaporate that quickly. They give you some idea of what pressure the fan is applying to the ground. There's a nice label there that has a bunch of information. So if we weren't going to do a YouTube, what would you rather see then? Are you talking about a electronic indicator for pressure failure, or would there be a
I would say
magnehelic gauge to measure the
in
pressure?
most
What would be better?
cases, we're mitigating homes that have high radon potential. So I think a digital monitor would be a great, a simple performance indicator. It tells us because a YouTube manometer can still be showing static pressure, but the system, for whatever other reason, might not be working as we expect it to. But I'm very curious on what Doug has to say.
Yeah,
I agree.
I guess I'm the old guy here in that give a history lesson. When we first started out in the mid 1980s, there was nothing. Then they went to lights that showed power to the fan. Well, just because you have power to the fan doesn't mean it's not locked up with Rocket J Squirrel. So then they went to YouTubes, which have stayed around a long time. But you're right, they're not very definitive. They pretty much tell you if the fan's completely dead or whatever. There are other methods out there. There are ammeters that show you the current draw of the fan, which I think are a lot better. When they first started coming out, we would get phone calls, about failed systems that we didn't get with YouTubes. And then now we're at a point where consumer radon monitors are actually pretty doggone good indicators. If you really want to get down to it, what are you trying to do? Control the radon. And the consumer models will actually show you a significant change that the homeowner looks at, as opposed to a vacuum. Now, one other thing that's happened in the States, at least through CARST, is a requirement of a audible pressure alarm. So in addition to the YouTube, the contractors are now putting in a pressure sensor that essentially beeps at 1 o'clock in the morning, telling the person that there's no longer a vacuum in there. But I have to say, Jean, that when we went to indicators, whether it's YouTube or whatnot, we were finding failed systems that we were not finding before, and the homeowners did not know that they had failed. So it's a critical piece, however you measure it, pressure, radon, or current, there needs to be something there.
Well, I put a bag at the exhaust. If it's a lateral exhaust, like on the wall, it's you can see in the winter that the snow is flushed. You have other indicators, You have other indicators that don't justify that. Then who is going to go there? Also, there might be some calls that are received from people who don't understand this imbalance. Is it normal? It's imbalance, but anyway, I am more concerned about the fact I use good product for the client to serve it the best possible, and then I put an inconsistency. There is a proper word to say to say that, but in this big Schedule 40 pipe, which is
And so as part of the CGSB standard, would it ever be considered to have a performance indicator and have a digital monitor serve as the performance indicator?
Well, Pam has posted in the chat room there, she said the current wording in the standard in section 5.1.7 under fan monitoring, it says each fan powered system shall have a device to monitor fan performance. So it's kind of up in the air what fan performance means, but it kind of saying you're measuring radon levels to indicate fan performance, that's a little bit of a stretch, but you can make that argument. It seems more like it's talking about, is the fan operating? Is it a pressure to the fan, power to the fan, that sort of thing. Yeah, I don't know. I don't see a lot of pushback from YouTubes in general because those things are just so darn reliable. Go ahead, Eric.
How about a little tassel tied to the stainless steel screen on the outside?
I suppose, but what's the real big argument against a YouTube? They're so easy. They're
it often tells us nothing. If in a very low static scenario, there's no difference between the two lines. And so it's causes confusion with the client because they say my level's at 0. It's not supposed to be at 0, but your system is actually performing lovely. But we have to go into explaining the reason and why did you put this thing on if it's telling us nothing.
Yeah, but I mean, if it's reading 0, you're moving a ridiculous amount of air. You have no obstructions whatsoever to airflow through your fan. So
you're not necessarily moving a lot of air. If you have a variable speed fan, you're potentially moving very little at low static.
Yeah, true. But in that case, then your tassel idea wouldn't work either. It's not going to be tassel.
I would ask the question, Colin, maybe to Pam, as far as the allowance of an actual consumer grade radon monitor to be the system performance indicator, especially when you're using ventilation techniques. In addition to ASD, the YouTube only works for an ASD system, when other aspects of the building are contributing to the reduction.
That's actually a great point.
Yeah,
that's a good point.
Yeah,
because there's no performance indicator for the HRV that it's working, I guess, unless you say maybe the internal display has to be attached to the wall and it has to have a display or something on it. That's fair enough. Well, let's ask Pam what she thinks about a radon monitor. But remember, a YouTube is going to last for the majority of these applications. The YouTube is going to show some useful information, and it's going to show it for many, many years without failure, or without relying on power. So I love the passive nature of the YouTube. But Pam, would you allow a radon monitor to be used instead of a YouTube?
Yeah, and I have just had discussions with professionals that they asked, would this be considered a device that would monitor fan performance? And to me, it seems logical. Practically in my home, it works for me. I have a radon monitor that shows me, so my system often gets frozen up in our -30 weather, and it shows me, oh, I'm frozen up again. So I have a very low flow, low pressure system. So my YouTube manometer doesn't show much. Plus, I never think to check it. I wouldn't, even me, I don't go down and regularly check my YouTube manometer in -30 weather. So the radon monitor is very effective. Also, one note in this, we are seeing photos and in conversations with homeowners, I don't know it's always being installed properly. So people need to remember that when they install the YouTube manometer, it needs to be installed level before the fan is plugged in, and then the fan is plugged in, and then you see the change. So yeah, it's a simple thing. It is a simple thing, but it's not always being installed properly. It's not always being interpreted properly by the homeowner or even watched by the homeowner.
Yeah, that should be covered in our mentorship. If they don't know at the end of their mentorship how to do the YouTube, then I've failed. You should fire me.
Well, that is true.
John,
what was Pam saying is relayed by those who were listening to Marcel this morning, and he says, well, a radon system can be installed and be successful, but when there's a move and another family comes in, it can be failing. So the U meter in this case is completely a wrong indication.
Yeah, that's right. Well, Jean, you've won the argument, and now you can take your $15 YouTubes, put them back in your truck, and now you can give the customer a $250 radon detector.
And that's the important thing to also consider, that you're documenting the fact that you're leaving that behind, because now if somebody moves, that radon monitor may go with them, and now you've got nothing for them to monitor the system. So you need to make sure that there's also that catch for the next occupant.
Maybe instead of a YouTube, there's a sticker then. I mean, this is best practice. This isn't something we're going to mandate, but maybe on the pipe there where the YouTube would be, where someone familiar would know where to look, maybe right there it should say, this system is being monitored by an electronic radon detector.
I
And
would
then
like to add that we have to go back to the beginning. The radon is a long-term exposure issue. It's not a small thing. And in my label, I say this system has to be checked in 2 years and then in 5 years after that. And so that way, it's the best control that everything is fine, and it's the best indication that, because I say to the people, you are going to spend all your time looking at the screen, saying you how many becquerel, and today it's in 86 and tomorrow it's 23, and what is happening, and then so this is consuming a power that is for nothing, and I am against that. I say just forget about it. You have been taken care of. Do your tests as required by my chart, and everything will be good.
Okay, that's a good point. Bruce, you've got your hand up there. You're on mute, and then Cody. Go ahead, Bruce.
Yeah, two quick things. I disagree with no monitoring of the system or radon measurement when you've installed a system. I don't like the waiting for 2 to 5 year idea for another long-term test. But Eric, for really low flow systems, have you considered a magnehelic pressure gauge? Because you can get those at very low range, low delta P. They're more expensive, a little bit more complicated, but they might work better than a YouTube.
I think a lot of things are cost.
Yeah, and I don't
because you don't want to add it onto the. I think even
someone needs to mute.
Yeah, I think I think for sure there's ways of measuring low pressures and showing it to the client, but I also feel like by showing them the pressure, we're taking this effort to show them one tidbit of information on the system, and then they kind of focus their attention on that one little bit of information that we can tell them, where there's so many other things. And I think monitoring radon, kind of, as Doug said, captures it all in one number that we care the most about. Energy use of the fan, I actually would like better, because it's showing the fan is, I don't even like it. I still don't like that though. Flow would be nice. Monitoring air flow through the system would probably be a way as well. And I guess you get these calls where the radon level might be fine, but the YouTube has changed ever so slightly, and the client thinks this is a warranty, a call worthy of a warranty visit, where you kind of have to start talking in circles to explain, like, here's a million things that could cause that thing to change. If your radon's fine and all these other things are fine, I don't think we need to go open up your system.
Right. So in other words, YouTube's not perfect, but for most cases, it's perfect enough. And Bob, you've got your physical hand raised. We'll go to you next, but then we got to go to Cody because he's got his electronic hand raised, which is easier for me to see if you raise your electronic hand. Just check out your Zoom screen there. But go ahead, Bob.
I couldn't find it on this Zoom screen, so I put my hand up. Anyway, two things. YouTube manometers are awesome as far as we're concerned, but we've had a number of, well, not a number, 3 in the last 2 years where the YouTube has actually slipped down and just needed to be readjusted. I hate doing 5-hour drives for a 2-minute service call. Second is that radon monitors, from my perspective, will show differences in the system due to atmospheric pressure, through wind, through all of that stuff. And we get the calls that say, the radon's now gone up to 110. Radon's, I like not to have those calls because I don't want any lack of confidence from a customer, and that's why we use the YouTubes. What does everybody think about alarms? Do we need
okay,
them?
we'll talk. Let's get to alarms after Cody here. Also, Michael Hollowell in the chat says, too bad we can't get a small and robust dial gauge. In fact, Bruce just mentioned the magnehelic gauges are available in low pressures as well, but they're going to cost you about $100 each, but they're very pro looking, but they're about $100 each. So those dial gauges are available. Cody, you've got your hand up there and you're muted right now. Unmute yourself and let's hear what words of wisdom we have from the Okanagan.
Hey, can you hear me, Colin?
Yes, we can.
Okay. So a couple things. I was actually just going to touch on what Bob was saying about alarms. That's number one. We can cover that after. The other thing is, I can't speak to what everybody else is doing, obviously, but what we do and what our concern is installing the best possible system that we can, of course, at the most affordable price while still making a living, right? What we do and what we like to do, because I'm not in the business of doing cheap systems or doing poor quality work, is at the end of our system, yes, we're going to put in the YouTube, yes, it gets leveled and all that. But what we include in the estimate and part of the entire job contract, documentation, all that sort of thing, is we actually will run a calibrated and certified CRM upon completion of the job, right? So I know we have to do follow-up testing. So number one is, are all of us as mitigators doing follow-up testing? That's important, right? So whether it's the actual client conducting that or we're conducting it with an approved detector, whatever it might be. So that's number one. Number two is that the vast majority of the time, either my client already has a digital detector or they're very interested in us providing them with a digital detector. Now, personally, we resell a lot of Airthings Corentium homes just because I've used them for years. We've tested them against CRMs countless times, and they've just been quite good, really. We found very, very little issues with them. So what we end up doing then personally is we'll take our CRM, our Corentium Pro or our Radar Eye Pro or whatever we're going to be using. We'll set that up. We'll put in the 24-hour delay, which is important. Remember that part, guys, or girls, sorry. And then what we get our clients to do, it's a little bit more work, but we'll get their detector, whether it's already pre-owned or whether we've provided a brand new one out of the box for them. And we'll say, look, our CRM is going to be starting at 5 p.m. tomorrow night. We're going to have your new detector, your permanent digital radon detector, on standby here, essentially. We want you to either insert the batteries or hit the reset button at 5 o'clock tomorrow night. And there's going to be a scrap sheet of paper here. And I want you to write down your levels and what time they are at when they start displaying for the next 48, 72 hours, etc. Right? So a couple things are happening there. We're getting them involved in the post-mitigation testing process. We're doing our due diligence in conducting that post-mitigation follow-up test, which we need to be doing. And now they have a permanent digital radon detector. Now, it was mentioned earlier, of course, hey, they might as well be taking that detector. I've just bought it. I'm gonna take my detector with me when I move to my next house. And that's happened countless times with our customers. And that's why it's important, yes, the documentation, yes, the YouTube and things like that. But that's why, just coming full circle again now to the alarms, it's an interesting concept because we know Radon Away, it has the audible alarm system, the pressure alarm and things like that. And what are other mitigators doing with that?
Mm-hmm. Yeah, a lot of good things happening. So Bob also mentioned he's driving 5 hours to check a customer's YouTube. So I think for a YouTube issue, you should get the customer to send you a picture. It'll save you 10 hours of driving. So I'd start there. Also, Bob, you're saying you're hesitant to have CRMs because the customer's going to call you every time there's a blip. And I think that's a reason why a lot of those Corentium homes are so good, is they give you the smallest time scale resolution is 24 hours. So you don't get those 1 or 2 hour spikes. It has to be a full day before they'll even see a bump at all. And it also could be in how we talk to our customers and what their expectations are. So it's a good idea to always tell them, oh, Doug's doing something, he's going to come back. One good thing for expectations is we say, look, the radon system on average, we designed it in this way, according to the standard, the pressures are very good. I'm expecting very low radon levels, but keep in mind that all radon systems are subject to upset conditions, right? Where things like abnormal winds, wind direction, wind speed, temperatures, all that sort of stuff can influence the radon entry for a short period of time. But the way we've designed it, on average, our annual levels in this building, we're expecting to be very low and well below the standard and according to our warranty or whatever we have. So I think setting those customer expectations so that they could expect to see upset conditions in some cases. I mean, I don't see upset conditions very often, but I know complicated, bigger footprints, more difficult to get your pressure field extension, you're more likely to see some upset conditions. And maybe saying that to the customer up front so that in the frame of mind is, yeah, he told me don't panic if the 1 day reading gets to 180. Don't call him. That's normal. Look at the long-term average and keep track of that one, because that's really tracking your health impact.
Colin, just a little follow-up.
Yep.
With regarding the system and documentation, which is obviously critical, what we've done over the past number of years is just getting our own stickers. And that's nice. I mean, for the guys, the guys that are in our area too, like Graham and Barry and stuff, I know you guys are on, spend that. It's like $2 a sticker maybe, and get just a professional looking sticker. Don't take the ones out of the YouTube bag. Yeah, like by all means, that do not tamper with and all that, those are fantastic. But I mean, for your own company, put your logo on there, guys and gals. Put in additional information according to our standard, the CGSB standard. There's all the required info that's in there, right? And then and you can put your certification number on there. You're not messing with it, and put a tick box or put what we personally have is just a comment section on the label that says or that we can add notes to, and we'll say, we'll put in there at the end of a job, sub slab depressurization achieved. And then whatever other notes we might need, et cetera, et cetera. There's, your CFM or whatever you want, right? Just a little bit, 2 bits there that it adds to the legitimacy and the professionalism of what we're doing. It's because I've seen so many other systems too. And again, I used to do it. I used to have these old chicken scratch little things that come with the YouTube manometers, and those are fine, but we're also professionals. And so we should also look the part, right? And so it can also add added benefit to the client, as well as provide you with further work down the road.
Yeah, great points. And I think the more professional you are, the better you're going to do. And maybe some people are a little bit lazy, we could say, because they're the only ones in their area doing a job. But that's changing. You're not going to be the only guy in your area doing a job going forward. So before you had it all to yourself, they're all calling you, you're getting all the work. I'm not saying you, but you in general. You're getting all the work, and you could do crappy work and you're going to get it all anyways. But you just watch, you're going to find people popping up in your area, and whoever does the best job, most professional, most diligent, best customer service, they're going to mop up all the other guys and get them out of there. So be professional and be proactive. I think that's awesome advice. We're running down near the end of our time here. We're not at the end. It's 11:13. We've got 11:30. That's 17 minutes left. I think Jean is raising his hand. And then after Jean, I'd like to get someone who hasn't activated their camera. Come on, you guys. I'm on page 1 of 3. There's page 2. There's page 3. No one's got their camera on. Let's get some activity going. Put something into the chat room. We have the last chance to get something you really want to know about off your chest or out there. We can give you some great advice. And please, let's stay engaged here. Jean, go ahead. You had your hand up. You're flashing me. What do you have to say?
YouTube. First question was, what do we do with that? Obviously, we do nothing with YouTube. Obviously, maybe the homeowner does something with YouTube. And YouTube is only indicating that the fan is running and moving air. In the great number of residential application, the exhaust is at a level that he can put his hand and feel that there is this blow. Isn't it enough? And then also we are concerned about all the rebus, all the waste that we produce, and it's waste for the future. It's plastic. It's going to feel I'm upset with that part of it too. So there is a hole in a big pipe. That's number one. That prevents the consistency. There is the use. We don't use it. The clients barely even use it. Plus, there is this possibility to check that some air is moving.
Right. Well, it sounds like there's some alternatives to the YouTube, although they may be more expensive, more complicated, and they may have more of an environmental impact than the simple YouTube. But it sounds like Pam is very comfortable with other methods, as long as they can be shown to demonstrate that the fan is performing. So we're not locked into the YouTube. It just became the front runner because of its simplicity, ease of use, and general well suitability. But there are other options, performance options you could do. And if you come up with something you want to promote, I think sounds like there's a market for it. Okay. Oh, Jean, you're not talking to us because your mic is off. Someone was asking about, let's see, how do you handle in-floor heating when requiring mitigation? This is from Ralph. Thanks for that, Ralph. Well, that's great. I did a course on that one time, actually, and it's not as simple as it sounds. So Tom's saying is an infrared camera, and Lance is saying is an infrared camera. For sure, but there's so many ways for in-floor heating to be missed by your infrared camera. And the only way to get good at missing in-floor heating pipes is to hit a lot of in-floor heating pipes. And I've hit so many of them that I'm now an expert at not hitting in-floor heating pipes. So I've learned a lot about how to avoid hitting them. Our record, I think, is, it wasn't me, of course, but one of my guys hit 4 in-floor heating pipes in one 5-inch hole. So that was a real treat to fix. Anyways, infrared cameras is definitely your go-to, but you have to use them correctly. Number one, you need a good camera. If you have the ones attached to your iPhone, okay, great starting point, but they're not very good and the resolution is very poor. And if you get a definitive in-floor heat signature, they work great, but sometimes you don't. Sometimes those heating pipes are down at the bottom of the slab. They're much fainter, right? They don't show up that well, and you can miss them easily, even with an infrared camera. Another reason, one of your zone valves is stuck and not working. So you've energized all the thermostats you know about, but you didn't get all of them. So there's even zones that you've missed. And of course, those zones all originate from the manifold in the mechanical room. So there's lines coming out from that manifold that are not indicating a thermal signature. So you could hit those at any time. The central zone pump is undersized. So when you turn on all the thermostats at once, maybe there's 6 zones, the system was never used to doing that. And that one pump divides its flow. And now we have such a tiny flow through 20 different zones that each of them aren't heating up very well. Another thing, the return zone. So you got this one pipe coming out hot, goes around 250 feet, comes back cold. If you don't let it heat up long enough, it comes back cold, you don't see a signature. If you let them heat up too much, sometimes it heat soaks the floor and you can't see any of the pipes. The best place with a thermal imaging camera, if you see a loop, I go straight for the loop. If you can see a loop where it doubles back on itself, drill inside the loop, right inside the loop. That's your safest place. If you see lines and you drill in between the lines, you're going to eventually hit some pipes because there's going to be a return line running through there. So look for the loop where it falls back on itself. That's the safest place to drill. But sometimes you need to corroborate a thermal imaging camera with other devices. So of course, in my videos, you see people using a Bosch Detect 150. That's a great tool for confirming the location of these lines because it'll tell you the depth that that pipe is at and what it's made out of. So you can make some good inferences from that, but it's a difficult tool to use. And a couple of years ago, I added a Hilti PX 1000, PS 1000, a ground penetrating radar. Very expensive, but you can actually scan a whole area and then paint a picture and see all the lines exactly and definitely miss them. So there's a range of ways you can do this, but I agree the thermal imaging camera is number one, but don't get misled. It is not perfect. And if you don't follow those rules about drilling in the loop and all the other things I said about the zone valves, you will start hitting pipes and they are a hassle to fix. You have to fix them with a repair coupler, can't be made of brass. You have to wrap it in tape and it's a big deal. So when you're doing in-floor heating, before you drill your hole, look for the expansion tank. So you know where to close the expansion tank off if you do drill into the hole. Look for the manifolds so you know how to turn them off, and look for all the zone valves so you can turn them off. And then you won't get hardly any liquid coming out of those holes, and you're just gonna have to fix it, number one. Anybody else here? Let's see, builder's return lines long, not easy to see with FLIR, that's right. I've got a fancy camera, a FLIR i8 camera, turn on for half an hour. Yeah, sometimes. Also, you're gonna run into this problem. Summertime, it's summer. You have in-floor heating. You tell the customer to turn it on. They go downstairs the day before or the hour before or whatever, or you turn it on. You turn the thermostat on. It's 18 degrees outside, Celsius for Doug. And the system won't turn on. Most boilers are smart enough to know that if it's above 16 degrees Celsius outside, they won't even turn on and even give you heat. So you have to now go outside, locate the outdoor reset temperature sensor and find it and get a pack of ice from the homeowner or a can of cold Coke from your lunch and put it over top of that sensor so it feels that the temperature outside is less than 16 degrees. It's the only way you'll get that heat to turn on. So this is a whole course in of itself. So I think that's a great comment there about the floor heating. Anybody else have any floor heating nightmares or strategies? Just unmute and go for it. Nobody's hit a lot of in-floor heating lines. Has anybody approached
we have, Colin, is that all of the same issues that you had is that especially return lines that weren't heated up enough. I will tell you that the floor in-floor thing that you used to scan with no longer available because I went to buy one for the new truck.
Well, the equivalent, Hilti makes one that's equivalent. It's the Hilti PS50. Get it on sale or get it used from their demo truck. It's the same unit. I think Bosch makes it for both people. So that unit is available through Hilti.
And what was
Gary, I
the,
see-
the other unit that you were using? The Hilti.
Oh, ground penetrating radar. Yeah, Hilti PS 1000. Yeah, but that's like a $35,000 tool. But you can actually image a 4-foot square, 4 foot by 4 foot section. Shows all the rebar, shows all your pipes, shows whatever's in there down to a depth of about 12 inches. So that's for commercial work. Yeah. Gary, Gary Bibby Fox, are you unmuted? Are you, you want something you want to add? No, doesn't want to add anything. Okay, anything else here?
Yeah, I was just going to add to the talk on the in-floor.
Sure, go ahead.
Can you hear me now?
Yeah, we can hear you. Go ahead.
Oh, sorry. Yeah, I just wanted to add to what you were saying about in-floor heat. We have tons of homes in the Kootenays here that are all in-floor heat, and we've hit numerous lines. And the latest one that we hit, just to debunk your drill inside the loop, we found they did a double loop. So there was a big loop, and then they did another loop inside that, and we went right through the second loop.
But how big was that big loop? Because if they're 1 foot centers, you'd have to have a pretty tiny loop. Or was this a big loop? Was this a big loop or a little loop? Because normally they're on 1 foot centers, and it'd be hard to put a second loop inside 1 foot centers. What was this?
It was
situation?
a 1 foot.
And they had a loop inside.
Poly, and it was a 1 foot loop with a 6-inch turn inside it. Another 6-inch loop. Yeah.
Wow.
Was it near an outside wall? You need to put a 3-inch and a 6-inch loop right up against the outside wall.
It was at the end of the
usually
slab, yeah, where it was
beyond
turning,
that.
obviously, to go back to the manifold.
So Lance, it sounds like you're saying you might find this around the outside edge of the slab where they're trying to make up for excess
So
heat
you cut
loss.
out
So
there.
they're putting more pipe in the ground.
Yeah.
Okay, good. Well, be aware of that. Then don't drill near the edge of the slab either. Let's add that to the list. If you don't want to hit pipes, and you will hit pipes. I saw Leonard. Yep.
Colin, I'm just going to say one thing, and then I have to go here. Then step back and look at an alternate approach, like weeping tile or a sump, or even coring through the outside foundation wall, because radon's stupid. It can go sideways as well as up. And so look at a different approach. But I want to thank you for having me in here. It's been a delight seeing everybody. You guys got a good program. I wish I could be more involved, but thank you very much. I've got a boogie.
Thank you for coming, Doug. Love to have you. Thank you. Okay, great. Leonard asked here, I thought something was interesting here. He said, do not core holes in basement with floor heat. Do them with a Bosch jackhammer. Okay, great. We'd love to hear your technique there, Leonard. You should unmute yourself and tell us what you're doing. That'd be great. But I have actually punctured quite a few in-floor heating lines using my jackhammer too, where I suspect there might be something there. I thought it'd be safer to use my jackhammer, and I've been using that one. So I've stopped using my pointed chisel, and I use a flat one. And I've been thinking about getting one made up with a ball on the end, so I could actually just hammer away without actually puncturing something. So to your point, I'm going to use a ball, like a 2-inch ball, steel ball on the end of a jackhammer to use that. And in the meantime, I will typically use my Bosch Detect 150. I'll scan, and I'm thinking there might be something there. I see something showing up. It could be the in-floor heating lines, but it's 2.5 inches down. So I'm going to core for 1.5 inches down, give me a head start. And then I've taken a railroad spike hammer. You know those sledgehammers that have the long, for railroad spikes, they're big long head on them like this and skinny. I took one in and I spent forever and I ground it into a ball. And now I switch to that and I just start tapping away like this. And that ball just pulverizes the cement and it digs down. But in my mind, it's not going to damage an in-floor heating pipe. It would just dent it and it would come back. And once the concrete chips off the surface of that plastic, I'd see that color show through. This is my idea. I think that might work. So Leonard, tell us how you are using a chisel to avoid in-floor heating. And do you have a special chisel, or what are you doing? Can you unmute yourself and tell us what you're doing?
He put in the chat, Colin, he can't unmute himself, but not to use the point, but use the chisel to prevent punctures.
Okay, yeah, that's what I've been doing too. Yeah, good point. I think that makes a lot of sense. So rather than drilling, you're gonna drill right through it, pulverize it, and it'll show up. but still be careful with those chisels. I have punctured some of that
Hey,
approach as well.
Colin, just
Yes.
before, we only got a few minutes left, but
Yeah.
I know for us BC boys, especially, I don't know more about, as you go further east, but like Barry touched on, we get some crazy difficult sub slabs, which you're completely aware of. And because our building practices and the codes over the years, we didn't have that same capillary break that I hear many of the other provinces do. So we're getting 3/4 minus or compacted sand and silt and bedrock thrown in and everything else you can find. We have a bunch of different things that we'll use to break up. If we can switch gears, if that's all right with you, because I just wanted to share Mitigator Round Table. We all struggle with the digging thing. I think that air nozzle was a great idea that Radon Away has come out with. I know we can all build that for $100 ourselves, and we're all going to do that anyways, because who's going to pay $2,000 for that, right? Let's be honest. But even we all got like SDS plus drills, right? Because we're all doing our 1/4 inch holes and all that stuff. Grab a chisel bit with an extension SDS plus on that. And if you're in hard to reach areas or whatever, or just real tight soils, take a 1.5 inch or 2 inch chisel bit that you buy for the SDS plus, just a straight, not the tile grinders or nothing like that. And literally file the edges down round, like what Colin was saying, on a round, essentially creating a round dead blow hammer. And just so now it's more like a spoon, and turn that just on the hammer drill mode, and you'd be amazed at what of a difference that makes. And you're not trying to literally get in there with a hand tool, and again, you don't want to be using drill bits and running through, because you start hitting water lines and stuff. Even though you've done your pre-drill assessment, you located the utilities, you're like, I think it's over here, I don't know. I just wanted to quickly get in there if other guys and gals have some good ideas about tough digging and what we can share, because again, we're all in the same business. We want to make this the most proficient profession that we can, right? And so we're all certified professionals. Let's all do this together, right?
Yeah, great point. I want to comment on your excavator thing there. You said you're going to build it a lot cheaper, which could be true. And I haven't looked too much into this excavator. I can't find any information on it, although they did email me the instruction manual. So I will take a better look at that once this is all calmed down here after today. But don't kid yourself, there can be some specialized stuff going on there, because I looked at that too, and I thought $2,000 US for a pressure wand seems excessive. But I've had that same idea for digging in the past, and the little bit that I looked into it was the nozzle. It's not just a pipe. It's probably not just a pipe with a hole in the end. It's not that. There are special converging nozzles that are being made that can actually accelerate the velocity to higher than the speed of sound. And that's actually what's causing these things to dig so well. So you can make one with a compressor, you can put it to 200 PSI, you can make a wand, drill a hole in the end and pull the trigger, and it doesn't explode the dirt. So you may have to do more. If you figured out, I'm always interested in hacking all these different types of devices. So if you figure this out, or someone buys one and we dissect it and we look at it, be very interested to hear about it, because it may be more specialized than we think. You see how big it is. It flows air very quickly. Yeah, great. Let's see, what's our time, Pam? Oh, it's 11:30. There we go. Well, we're not going to turn to pumpkins, but our time is officially over. If you want to drag on for a couple minutes after, that's great. But thanks for coming. Do you guys think this Mitigator Roundtable is worth it? Is this something we should be doing routinely, or is this something we should? I see some thumbs up. I see some nodding. There wasn't a ton of participation, but the people that participated had ideas that seemed to be common ideas. So, I mean, it's just, maybe that's just the limitation of our platform here. Thank you guys so much for coming. Really appreciate it. Let's continue to share ideas as much as possible. We're all in it together, like Cody says, and we all want to do awesome professional work. So with that in mind, is there anything else you want to say, or do you want to talk about the next sessions or anything like that? No. So next session is, I have a PFEDK, or is it piping? No, PFEDK. The next session, which starts, is it half an hour, Pam? Yeah, she's nodding, half an hour. Okay, at 12 o'clock, we're going to talk about the PFEDK, that's Fantech's pressure field extension diagnostic kit. I'm really keen on this device. It does everything you're doing now, but it does it faster and better. And we're going to do a full demonstration of this thing. I hope to see you there. And that's it. But in the meantime, I'm here for a couple minutes before I have to take a bathroom break, if anyone wants to go through anything, but our time is officially over. Anything else on your mind you're too shy to say before?
Hey, Colin, Frank was asking about your ground penetrating radar.
Yeah, that's very expensive. maybe I can send you one if you want to borrow it or something. Maybe I can loan it to you and send it out to you to try it out first. Don't use them very often, but again, it's like that another expensive tool that when you need it, there's no other tool that can do that job. So I primarily use it for commercial work because I'm in Timbuktu or something, and to hire these guys in to do ground locates and whatnot can be very expensive and complicated. And then they always bugger off right away. And after they're gone, I think of 4 more places I'd like to have a hole drilled. So it doesn't help me at all. And I figured if I just did it myself, I could be confident in drilling my own holes. So that's why I bought it. I don't know if there's a huge use case for it for residential work. But having said that, I have used it on a residential job and I have no hesitation to pull it out of the truck. It's too expensive to let sit there. So ground penetrating radar takes an actual image, an actual radar image in the ground, and can show you on your monitor, on your iPad, or on the screen itself exactly what's in there. It shows it to you. And then there's a grid you're scanning through, and you look on your image and you find a spot on the grid that's safe to drill through, that doesn't have any target in there you don't want to drill through. And you find that on your grid on the floor, and that's where you can drill, and you're safe, not going to hit anything, but it's expensive. Yeah, John?
Won't you need a certification to manipulate this tool?
It's probably a good idea. There's no laws against, they're not going to not sell it to you. So when you buy a tool like this, like through Hilti, they have training they provide you on how to use it, and they'll send people out to your job, which I've done. So I don't know if any real certification. If I was doing it for a living, I guess maybe then there might be something, but every time I've hired someone to do it, they just sent some Joe Blow who doesn't usually know how to use the thing properly. So yeah, probably a good idea to get some good training or certification on it, but I'm using it for myself. Hey, Maureen, is your arm up or are you just scratching yourself? She's scratching herself. Okay, well, thanks guys. Let's keep in touch. And I hope to see you at the next session. I think it's gonna be a really good session. Thanks, Brooks. Thumbs up to you too. Have fun, everybody. Okay,
Thanks.
I'm gonna talk to you later.
Thanks.